Lesson 1.3, Using Midpoint and Distance Formulas. Let's take a look at a segment on a piece of paper, and let's visualize a midpoint. If you were to fold point B onto A, making sure all the points on the line match, and then unfold it, you would see that where at the fold, you would be finding your midpoint because this length will be the same as this length. Our essential question, how can you find the midpoint and length of a segment in a coordinate plane? Before we go any further, make sure you set up your notebook, the heading of the notes, the essential questions, and here you can see a list of vocabulary words and spots for formulas. You can stop the screencast at any time to copy down the notes and then resume when you are ready. In a skateboard, segment VW bisects segment XY. So this is segment VW. It's actually doing the bisecting, which it means to cut into two equal pieces. And we can see that the pieces are equal because there's a tick mark here and a tick mark here, meaning that they're the same size. We know that XT is 39.9 centimeters, and the question is to find XY. So we're going to use the segment addition postulate. The big distance is equal to the two little distances, which are exactly the same. Now, since 39.9 is really close to 40, this answer is really close to 80, but it's slightly shy, so it's 79.8, and the answer is in centimeters. Okay, so what we've been talking about is a midpoint. This is our vocabulary word. Take time to copy the picture of a midpoint and take time to copy the notation. If we do have a midpoint, these two segments are congruent to each other. That means the set of points match each other, and their lengths or distances are equal to each other. Our next vocabulary word is segment bisector, and a segment bisector can be a point, ray, line, line segment, or plane. Copy this picture. You can see the green line is the segment bisector. So it's actually this, a line. So that's the example that we're seeing. And again, a segment bisector will create this idea of congruency and equal distances. Okay, let's go to this problem right here. We can see that we want to identify the segment bisector and then find PQ. Okay, so this is the segment bisector because that's the midpoint and this is the one that's doing the cutting. So the answer to the first part of the question is the segment bisector is ray MN. And this is how we would write it, making sure that the endpoint is first. The question is to find PQ, so PQ will be using the segment addition postulate, this length plus this length. Now, 0.78 is the same thing as 0.875, so you can change it to a decimal. And then when you add both of them together, you get 3.75 as your answer. All right, what is the segment bisector here? You can see the only thing that's going through the midpoint is a point, so the answer is point M. And PQ will be equal to 2 2/7. I'm not going to change it to a decimal because I would be creating a repeating decimal. So the answer is 4 4/7. All right, point M is the midpoint of this segment, and we want to find the length of VM. So we would like to find this length. So what we would like to do is set the two lengths equal to each other, do some algebra, and x will be equal to 4. This is not the answer to the question. It's the answer to what x is. So VM will be equal to 4 times 4 minus 1, and the answer is 15. Identify the segment bisector for PQ. This is the segment bisector. So the answer to the question is it's line L. Now we'd like to find MQ, which means I'm going to set the two lengths equal to each other. Solve for x and x is equal to 2. Again, this is not the answer, but it is the answer to help me find MQ, which is right here. I'm going to put 2 into there. So 11, take away 2 times 2, and the answer is going to be 11 minus 4, which is going to be 7. And that'll be the length of MQ. Identify the segment bisector. This is the segment bisector. It's going through the midpoint. The answer is line N. And we go through the same process, setting the distances equal to each other. And we're going to get 2x is equal to 15, x is equal to 7.5. And to figure out RS, we'll be finding the length of one of these and then doubling it. So I'm going to put 7.5 right into here. So RS will be 2 times, and I'm going to do 4 times 7.5 plus 3. So this is going to be 2, and that's going to be 30 plus 3. That's 2 times 33. And then the answer is going to be 66. So that'll be the length of RS. Find the midpoint of segment AB. So here's segment from A to B, and we want to find the coordinates of this midpoint, somewhere in between here. Now let's go ahead and make this right triangle, and this point will be the point. It's going to have the same x coordinate as that one, and it's going to have the same y coordinate as that one, which is -2. And I'm going to try to find the midpoint along the horizontal, and I'm going to be using the 2 x's. And to find the middle means to find the average. So I'm going to take -5 plus 3 divided by 2, and then this is going to be -1. So at -1 is the halfway point, and you can see 1, 2, 3, 4 units to the right, to the left, 1, 2, 3, 4 units to the right. So that is going to be the midpoint from here to here. Now I'd like to find the midpoint between the y coordinates here. And again, I'm going to find the average, and then this answer will be 1. So right here at 1, that's the halfway point at 3 units here, 3 units here. Now if I were to go across here, and I were to go up here, this point right here that has an x coordinate of -1 and a y coordinate of 1 is what we call the midpoint of segment AB. Okay, what we just did is what we call the midpoint formula. And this right here is what I did with the actual numbers. I took the x's, added them up together, divided by 2, and that'll be the x part of my answer. And then I took the y's here and divided by 2, and that'll be the y part of my answer for the midpoint. All right, let's go ahead and do some examples. I'd like to find the midpoint. So I'm going to take the 2 x's, add them up and divide by 2. So midpoint M will be equal to 1 plus 4 divided by 2. Now I'm going to take the 2 y's, which is -3 plus 2, and divide by 2. And if I simplify, the answer is going to be 5/2, and then this answer will be -1/2. So this will be the midpoint. Now let's take a look at what would happen if I was given the midpoint. So if I was already given the midpoint at 2, 1, and one of my endpoints was J, they're asking us to find the other endpoint, which is K. All right, so let's go ahead and write this up. My midpoint is 2, 1. One of my points is J, which is 1, 4, and the other point, I don't know. Okay, according to the formula, I'm going to take my 2 x's, I'm going to add them up, divide by 2, and this will be my answer, which is 2. If I cross multiply, I'm going to get 1 plus x is equal to 4, and therefore x is equal to 3. All right, to figure out the y, I'm going to take the 2 y's at the endpoints, 4 plus y, divide by 2, and I know that the answer is going to be 1. I'm going to cross multiply, and I can see that my answer will be negative 2. So the answer to this k, point k, will be 3 comma negative 2. And if you look at my diagram, there I am right here at 3 negative 2. Okay, why don't you try it? Stop the screencast and try this on your own, and then go ahead and start it up again. And I'll go ahead and write down the answer after you try it on your own. Okay, so this particular answer, m, will be equal to 1 plus 7 divided by 2 and 2 plus 8 divided by 2. So the answer will be 4 comma 5. Now here's one of those problems where the midpoint has been given, one of the endpoints has been given, and we are to find the other endpoint. Now we can go through the process I showed you a few minutes ago, or you can do something else. Knowing if you have a graph like I have, then what you can do is you can say, well, to get to the midpoint I have to go up 3 units and over 1. So to get to the other endpoint, I'm going to have to go up 3 units and over 1 as well. Now remember, the midpoint was this, so you will have to go over 1 unit, that'll mean 3, and it'll have to go up 3 units, and up 3 units for 4 is 7. So instead of going through all the algebra I showed you before, we can actually use the graph to help us. Our next item is to find distance AB. So the distance from A to B, we would like to find that distance. And again, this point is 3 comma negative 2. Again, it matches the x's here, it matches the y's right here. Now, this distance right here, we can just take the 2 y's. We can take the absolute value, 4, take away a negative 2, absolute value, and the answer is 6. You can also actually just count and see that this is 6 units as well. Now we can take the x's and we can take the absolute value of their difference, and this answer will be equal to 8. Or you can just actually count all the units and see that it's 8. Okay, when this is done, we have a right triangle and we can actually find AB, which is a hypotenuse squared, is equal to 8 squared plus 6 squared. And then to figure out AB, I'm going to just take the square root of 8 squared plus 6 squared, which will be root 64 plus 36, which is going to be root 100, and the answer is 10. All right, now what I just did was the distance formula. Remember how I took the absolute value of the difference between the x's. When you take this number and you square it, you no longer need the absolute value sign. Again, I'm taking the y's away, and it's the absolute value, but since I'm going to square it, I can drop the absolute value, and I have this. So here is the distance formula. All right, so let's try to figure out PQ. PQ, you can see that these are by 5s, by 10s, I'm sorry. So this is 10, 20, 30, 40. So distance PQ is 40, distance QR, and these are going by 10 again, 10, 20, 30, 40, 50, 60, 70. So this distance is going to be 70, and we'd like to find PR. So we can actually just use the distance formula. PR is equal to root, and then we're just going to do 40 squared plus 70 squared. And this will be 1600 plus 4900, and this will be the square root of 6500. And 6500 is 65 times 100. Square root of 100 is 10, so it's 10 root 65. That's the way to do it with a Pythagorean theorem. The other way to do it is with points. This point is 10, 50, and this point is 80, 10. And you can actually find the distance using the distance formula. So I would take away the two x's. So that'll be 80, take away 10, squared, plus, now we're going to take away the two y's. So since I started with 80 here, I want to start with 10 here. 10, take away 50, squared. This number will be 70, so this will be 70 squared. Notice how that matches with the 70 I have up there. And this is going to be negative 40, but when you square negative 40, the answer is going to be positive. So I'll write negative 40 squared, but I know that when I square it, I will still get the same answers I did over here. I'll get 4,900 plus 1,600, and that will simplify to 10 root 65. Okay, our last problem. This is our exit ticket. Why don't you try this problem? Stop the screencast, get all of those answers, and then when you restart it, I will show you the answer. Okay, we're back, and here's the answer. You can see I found the midpoint by averaging the x's and averaging the y's, and I figured out the distance using the distance formula, but I also showed you using the Pythagorean theorem. And this is the end of lesson 1-3.